Hello everyone, good morning. We will continue with the second state of matter, which is the liquid. It's interesting to know that our Mother Earth is the only planet in the solar system with a mostly liquid surface. It's oceans. If the Earth were a little bit closer to the sun, the oceans would run into vapors. If the Earth were a little farther away from the sun, most of its surface would turn to be ice. So, Alhamdulillah, Earth is located where it is now. In the liquid phase, molecules can flow freely from position to position by sliding over one another. And the liquid take the shape of the containers here. And mind you, our bodies are composed of more than 60% of water. At the end of these lectures, it will help us to understand what do we mean by pressures. Then we will discuss the pressures in air and in liquid, and the buoyancy force in liquid, Archimedes Principle, what are the rules which will make an object sink or float, Pascal Principle, and we're ending by studying surface tension and capillarity. Let us start with pressure. What is pressure? When an object exerts a force on another object, we say it has a pressure. It's making a pressure on it. So pressure is the force per unit area that one object exerts on another. In mathematical form, pressure equals force divided by area. These forms tell us a lot of physical meaning for the pressures. For constant area, the pressure will be directly proportional with the force. More force, you will have more pressures. But if we have a constant force, if the force is constant, there is a reverse relationship between pressure and the area. If we increase the area, the force acting on it, the pressure will reduce, and vice versa. So pressure will depend on the area and will depend on the force there. The unit for the pressure is force divided by area, which is Newton divided by meter square, or we call it Pascal, BA. Let us think about this example. The teachers lie between two beds of nails here. And when you acting by the force on this bed, he is unharmed. Give reason why this happening. Obviously, because force is applied not only in one nails, but over many nails, so there is a combined surface area of the nails together, result in a large area in which we have in a safely small pressure that does not cut the skin, and the teachers will not be harmed. So increasing the area, it will reduce the pressures, so he is safe. Another example, this block could be stand in upright position or in a side position. Which one which will exert more pressures on the table than the other one? In upright position, the area is small. In the side position, the area, contact area for the force, is large. So the pressure in the upright positions will be more than the other one. So the upright block will exert greater pressure against the table than the other position. Pressure equal force divided by area. Area is small. Force is the same. The weight of the block is the same in both cases. So the pressure will be increased. An inverse relationship between pressure and area. Now, why do we have air pressures? Air consists of many gases which have molecules. Molecules have mass. So all the weight of this mass will exert a force on the Earth's surface. So it will have a pressure here. So the pressure of air is due to the weight of air on the surface of the Earth. Obviously, if the coulomb of air here is high, the pressures will be high. If you go to the mounting here, the coulomb will be less, so the pressures will be less. So the pressure on Earth will be different at different locations, depend on the height. If you go to Hafid's mounting here, it's nearly 1 kilometer above the sea level. The pressure on the Hafid mounting will be less than the pressures on the surface, on the water surface here. Why? Because the weight of air here will be less than the weight of air in this one. Pressure here will be less than the pressure in this position. In these slides, we do just a simple mathematical transfer to have a new equations to indicate more parameter controlling the pressures. We know the original pressure equation, that pressure equal force divided by area. If we can do these simple transformations, we can come to the conclusion that pressures will be equal to the density multiplied by the depth multiplied by the gravity. Gravity is constant, so pressures will be directly proportional with the density of air, and pressures will depend on how much depth, the height of the coulomb of air above the Earth. Pressure equal density multiplied by depth multiplied by gravity. The tower, this tower, store water. It's a high one. The depth is high. And gravity is constant. The density of water, you know the density of water. So we will have a substantial pressures at these locations with high pressures. So if we connect a pipe from here to the household nearby, will be a different in pressures between the tower and the home. This is high and this is low. And the normal law that the liquid will flow from high pressure to the low pressure. So this will ensure substantial water pressure to the mini home it will serve. Remember our equation, liquid pressures will be equal density, depth multiplied by the gravity. So we know the depth here or the height of the tower. Then we will have substantial pressures which will make sure that the waters will flow to the many homes it serves. Let us think about this example. When you stand on 1 foot instead of 2, the force you exert on the floor, is it less or the same if you have if you use 2 foot, or more, or none of the above? Think about it. The obvious answer that the force does not depend on the area in this case. So if you stand on 1 foot or 2 foot, you will have the same force acting on the floor. Let us go to the second example. It's the same one, but this time we ask you about the pressure. How much pressure will be exerted by your body if you stand on 1 foot rather than 2 foot? Is the pressures which you exert on the floor It will be less, it will be the same, it will be more, or none of the above. So what's your answer? Since we're standing only on 1 foot rather than 2 foot, so the area will be less. When the area is less, the pressure will be more. So the answer here is C. Now let us move to the pressure in a liquid. Pressure in a liquid is what? It's the force per unit area that liquid, the weight of the liquid, exert on an object. In this case, please note that liquid pressure is depth dependent, not volume dependent. To explain this further, if you swim as twice deep in a pool, then you will have as twice much weight of water above you, and this will produce twice as much pressures on you. Now if you go to the sea, more volume of water, and again you swim twice as deep, then what happened? Again, you will have twice as much weight of water above you. It does not depend on the volume. It only depends on the depth, right? So it's important to note that. Another example to demonstrate the effect of depth, that when we have dam, we're building a dam to have a reservoir of waters behind it here. So the water pressure acting against the dam will depend on what? We have, in this case, case A, we have a large shallow lakes. Large lakes here, but it's shallow, it's only 3 meters. The second case, we have a deep pond here, a deep pool with a depth 6 meters. It's less water, but which one will exert more pressure on the dam? Obviously, the pressure is depend on the depths, so you will have more pressure if you have more depths. So the second case, where you have 6 meter depths, will exert more pressure in the dam than the first case when you only have 3 meter depths. Notice the thickness of the dam in both cases. This is much, much bigger than this one, wider than this one, because it needs to withstand a high pressure, and this one, the pressure is small. So this dam need to be more strength than this one. So at the conclusion, liquid pressure is the same for any given depth, regardless of the shape of the container. So the pressure here, pressure at the same depths will be the same, regardless about the shape of the vessels containing the water. Now we are going to move to another concept of liquid, buoyancy in liquid. We know that if we completely submerge an object in liquid, it will displace a volume of liquid equal to its own volume. This is the rule, the displacement rule, that a completely submerged object, it's always displace a volume of liquid equal to its own volume. Let us try here. When we have a stone, we don't know the geometry of the stone, so we don't know the volume of these stones. One way of measuring this the volume of the stone is just to submerge it in a water. When you submerge it in a water, the water level will increase. If we have a scales here, we can measure how much increase in volume, and the displaced water here will be equal to the volume of the stone. Or we can collect the distilled water here and see how much volume, and the volume of the distilled water will be equal to the volume of the stone or the rock. Let us have this example. When you have a submerged object in a fluid, how many forces act on the submerged body at rest in the fluid? Is it one force, two force, none, net force, and none of the above? Which one you choose? Give me your answer. Obviously, when we have an object submerged, body submerged in a fluid, it will have two forces acting on it. The first one is the gravitational force acting downward. The other one is the buoyancy force which is acting upward. So always we have two forces on a submerged body, the gravitational force and the buoyancy force. They are in opposite direction. Archimedes Principle. This principle discovered by the Greek scientist, this is a Greek scientist, look very pretty, Archimedes here. What's he done? He relate the buoyancy force to the distilled liquid, and he come up with the principle state that an immersed body, either completely or partially, part of the body will be immersed or the whole body will be immersed. In this case, it will be buoyed up by a force equal to the weight of the fluid it dispels. And this Archimedes principle will be applied to the fluid, which means will be applied to the gas as well as be applied to the liquid. The fluid is gas or liquid. Archimedes principle can explain the fact that objects weight more in air than in water. If you weight an object in air and you weight it when it is immersed in water, they will have a different weight. This weight will change. So we call this apparent weight. And this apparent weight, الوزن الظاهري, could be obtained from the equation that the apparent weight will equal to weight in the water minus buoyancy force. Let us see this example to illustrate what happened here. If we have a 3 kilogram block, we weight it in air, and the weight here is 3 kilogram as indicated here in the balance. If you submerge this object, this block, in water, then you will notice that the balance read less is only 2 kilogram. This is the apparent weight. Then this is because of the buoyancy force. We have 3 kilogram will have a weight down and buoyancy force up. They are opposite in direction, so the resultant will be the submerged or the subtractions of both. We need to know how much the buoyancy force. Buoyancy force could be, know the value of the buoyancy, if you collect how much dispel water here. If we weight this volume of the distilled water, which will be equal to the volume of the body, we find that the weight equal to 1 kilogram. So the buoyancy force is 1 kilogram. The force, the weight in air is 3 kilogram. If you subtract the weight in air minus the buoyancy force, which is 1, it will give you the apparent weight, which is 2 kilograms. Let us see this example and try to understand what's going on. We have a submarine here, Al-Ghawwasa, which expel water from a bulk tank. Let me explain first how this submarine works. It can float on the water, or it can go deep under the water. And this is being done that this submarine have tanks inside it. If the tank is open and we fill it with water, then the weight, the mass of the submarine will be more. Then it will go down. Now, if it will go down, why? We have a buoyancy force up, we have the weight down, which is equal to the mass multiplied by the gravity, right? Since the mass is higher, then it will go, the mass higher, the weight will be higher, then the submarine will go down. Now, when the submarine expel water, it take water out from the tank, what happened? It will flow on the top. The question here, what happened to the density of the submarine? Is it decrease or increase or remaining the same, or none of the above? If you recall, what do we mean by density? Density equal mass divided by volume. The volume of the submarine is constant. When you expel water from the bulk, you take water out, which means that the mass will be less. Since the mass will be less, the density of the submarine will what happened to it? It will decrease. When the density of the submarine will be less than the density of water, then it will float up. If the density of submarine is greater than the density of water, it will go down. So, does it sink or does it float? The buoyancy force on a submerged object will depend on its volume. A smaller object will dispel less water, which means you will have a smaller buoyancy force act on it. Smaller buoyancy force when we have a smaller object. What about if we have a larger object? A large object will dispel more water. A large object which has more volume, it will dispel more water. This will result of a large buoyancy force act on it. So the submerged object, the object volume here, not its weight, this is the one which will determine the value of the buoyancy force. And buoyancy force will determine if the object will float or sink. If the buoyancy force is less than the weight of the object, it will sink down. If the buoyancy force is greater than the weight of the object, it will float down. If they are the same, then it will be suspended, as we can see from this example. This is an interesting example here. We ask you, give reason. If you have a solid 1 ton block of iron, it will sink in the water. Why it will sink? Since the buoyancy force is very small and the weight is very large. So as the result, weight is larger than the buoyancy force, so this will sink down. Now, if we have the same ton here, but we reshape it to take the pool shape like that, In other words, we increase the volume of the bulk. Rather than the small volume, we increase the volume. When it's submerged here, the buoyancy force will depend on the volume. So we'll have more buoyancy force in this case than in this case. You will have large buoyancy force there, and the weight will be like that. If we increase it 8 times, to have 8 times volume greater than the bulk, then this will float up. It will not sink down. The reason why that the buoyancy force and the weight of the iron will be nearly the same, and the irons will be suspended, will be float in the water. Question: what is the reason a person finds it easier to float in the salt water compared with the fresh water? So it is easier to swim or to float in a salt water than fresh water. What are the difference between these two types of water? Salt water is more dense. It has more density than fresh water. Fresh water, the density of fresh water is 1 gram per centimeter cube. Salt water will be 1.03 gram per centimeter cube. It's higher than this. So in this case, a reason a person finds it easier to float in a salt water compared with the fresh water is that the salt water have a buoyancy force is greater, or a person feel less heavy, or neither of these, or none of the above. You have to choose between one of these answers. I'm waiting for your answer. The buoyancy force is greater. Why the buoyancy force is greater in a salt water than in fresh water? We have a person which have the same volume. When it will go to the fresh water, it will expel a water which have the same volume like the person. But because of the density is 1, the weight of this expelled water will be less than, which this weight will be equal to the buoyancy force. So the buoyancy force in the fresh waters will be less than the buoyancy force in the salt water. In the salt water, same person, same volume, so we'll dispel the volume of the person. The density of the salt water is greater, so the weight of the salt water will be great, the dispelled water will be greater, so the buoyancy force will be greater. So the buoyancy force in the salt water will be greater than the fresh one. This is the explanation here, that denser fluid will exert a greater, the salt water is denser than fresh water. This will exert a greater buoyancy force on a body than less dense fluid, which is the fresh water, which have the same volume, because the immersed body have the same volume here. Now, question for you. As you sit in the chair in the class, is there a buoyancy force acting on you? Anything which will be dispelled? When you come, you are here, the chair is there. When you sit, there is a medium between you and the chair. We have air. When you sit, this air will be dispelled out. So we'll have a buoyancy force, but it is so tiny. The density of air is so small. So the weight of air is so small. So the buoyancy force is small. You cannot notice that. But this is nevertheless, yes, you will have a buoyancy force when you sit in the class, and this acting on you. This is due to the displacement of air when you sit on the chair. This slide summarizes the rules for does it sink or does it float. We have wood, we have stone or rock, and we have fish. What are the difference between all this? The density of the wood will be less than the density of the fish, and the density of the fish is less than the density of the rock. So the wood, which have less density, will float because it is less dense than water. Rock or the stone, the rock will sink down since it is denser than water. But with regard to the fish, it is neither rises nor sink. Why? Because it has the same density as water, so it will be suspended there. The buoyancy force will be greater on lead or aluminum, or both have the same buoyancy force, or there is not enough information waiting for your answer. Please remember, both have the same volume. The buoyancy force, it depends on the volume, not on the weight. Since both of them have the same volume, so the buoyancy force on both of them will be the same on both blocks. In spite of the fact that we have two blocks of different weight, lead is much greater than aluminum. But in both cases, both of them have the same buoyancy force because the volume of both of them are the same. Now, let us move to one of the property of the fluid which been discovered by Pascal. We call it Pascal Principle. What is Pascal Principle? Pascal Principle states that a change in the pressures at any point in an enclosed fluid, we have closed system here. Fluid which been set on a closed system. Closed vessel. So any change in the pressure at any point of this enclosed fluid at rest, this change will be transmitted undiminished to all points in the fluid. We will discuss it further, and Pascal Principle, it's applied for all fluid, which mean gases or liquid in the system. Pascal Principle could be applied. If we have a piston, we have a closed system here, we have a piston here. If we exert pressure in this piston, the pressure here will be spread, transmitted through all points of the fluid up to the other side. So when you push it here, the force or the pressures will increase. I'll come to this, and this will be coming up because the pressures will push it up. So the force exerted on the left piston here will increase the pressures in the liquid, which will transmit to all points of the liquid, and it will lift the right piston up. And we have another area, larger area, 15 times more. This is a closed system. Now, if you apply pressures in this area, the pressure will be transmitted all over all parts of the fluid. Remember, pressure equals force divided by area. So when the area is increased, the force also will increase to make the pressure here constant. So if we apply pressure to the left piston here, only 10 kilogram is being applied to the left piston here. So this 10 kilogram will exert pressure on this surface of the area A. These pressures will transmit to the right piston. Each area of it, A, will have a pressure of 10 kilogram over the area A. But if you have this area is 50 times more than this area, this is mean that we have force 50 times more than this area. So by applying 10 kilogram load on the left piston, you can carry a weight of 500 kilogram load on the right piston, simply because the area here is more. The golden rule for this equation, for this example, that F1 divided by A1 equal to F2 divided by A2. This is Pascal principle. We lift it up. Using Pascal principle, we have a closed system of fluid, liquid. If you make a force through a compressed air coming through, force here, this force will exert pressure in this one. The pressures will be transmitted to all part of the fluid, which will make a huge force, which will be able to lift the car up. This is Pascal principle in action. Now, lastly, we are going to talk about surface tension. When we have liquid, the surface of the liquid had tension. We need to explain why do we have surface tension on the surface of the liquid. So surface tension is mainly caused by molecular attraction. What does that mean? When we have a liquid like that, the molecule inside the liquid will be surrounded by other molecules, and it will be an attraction between molecule and all other molecules surrounding there. So the net force acting on this molecule inside the liquid will be equal to 0. There is an attraction, this force in this direction, another force equal and the opposite in the other direction. So the net force nearly will be equal to 0. But if the molecule on the surface, you have a liquid molecules inside and air molecule outside, the attraction inside will be more than the attraction outside. So a molecule in the surface of the liquid is pulled by neighbor of each side, it will pull down. So this will cause tension on the surface, and this is the cause of the surface tension. And the surface tension can explain why if you just strip a water through a small pipe, it will come up in forms of sphere. Why sphere? Again, surface tension will reduce the area of the liquid to the minimum, and the minimum area exists in the surface is the surface of the sphere. So this will become sphere like that. Surface tension will be affected by some physical factor. First one, what type of liquid do we use? Are we using oil? Are we using waters? Are we using another type of liquid? So water has a greater surface tension than oil. Then, do we have pure liquid or this liquid mixed with another liquid? So what is mixed with the liquid? Soup water, for example. Soup, if you're adding to the water, we will have soup water. This has lower surface tension than pure water without soup. So what is the type of the liquid? This will affect the surface tension. And what is mixed with the liquid? This will affect the surface tension and also the temperature of the liquid. If we heat the the molecules in the liquid, then they will take the energy from the heat and they are vibrating, so the distance between them will be further and further. So the molecules in a hot liquid have higher energy and are not bound tightly as in the case of the cooler liquid. Cooler liquid, molecules near each other, so the attraction force is a little bit high. But if you increase the heat, the molecules will vibrate and it will be distance apart from each other. And because of that, the attraction between them will be less, and this will affect the surface tension. So 3 main factors affecting the surface tension. What type of liquid do we use? What is mixed with this liquid? And the temperatures of the liquid. The cohesion force is much greater than the adhesion force. So surface tension here, if you probe the surface tension, probe the bonding between the molecules here, this is will cause the film on the surface to contract. The surface tension cause contract for the surface. If you cut them, this is will raise the liquid from below to up like that, and this is capillarity. It will rise until it will have a balance. When the force of the surface tension balance with the weight of the liquid down, the force of the surface tension take it up, weight of the liquid is down. When both of them are equal to each other, then the liquid stop, and we'll have this raise in the surface of the liquid. This is a capillarity. What factor which will affect the capillarity? There is 2 main factors affecting the capillarity. What is the weight? What is the weight of the liquid, and what is the tube radius? If you have the lighter liquid, when the density is less, this will cause a higher capillarity rise. Lighter liquid will raise higher. If you have narrow tube will cause a higher capillarity. More liquid will rise. If the radius will increase, then the level of the liquid inside the tube will decrease. All the liquid come up have the same volume. If you increase the radius, then the height will be different. The height will go down, but the volume of all the liquid will be the same. So this is explained why if we have an R1, you will have height higher for the capillarity. If you have a larger one, the height will be lower. This is capillarity in action. If you are in a hostel and going home, and you have some plant which will die because there is no water, you can do this arrangement here. A tank which will have more water, then these threads which act like a tube, very thin tubes. So the water will go through this tube to the plant and it will irrigate it, so it will not die. It can stay for a month like that. So this is capillarity in action. Now let us do some assessment questions for these chapters. The first questions: water pressure at the bottom of the lake will depend on what? Is it depends on the weight of the water in the lake, or the surface area of the lake, or depth of the lake, or density of the water? Waiting for an answer. Remember, pressure does not depend on the volume or the weight, does not depend on the surface area, is only depend on what? Depth. So the proper answer for this question is C. Depth of the lake is the one water pressure at the bottom of the lake will depend on the depths of the lake. You remember this example about the dam. When we have a shallow lake behind it or a deep pool behind it, the pressures will be more if you have deep pool. Depths is more than the other one. Okay, let us go to the second assessment. If you have an object submerged in water, and this object will cause a displace of water of mass 20 kilogram, then what is the buoyancy force that acts on that object? Choose from these four options. We are asking for the buoyancy force, and the force with the unit of Newton, so obviously the first answer is wrong. How can we calculate force? Force equal mass multiplied by gravity. You already know the mass, which is 20 kilogram. We already know the gravity, which is 10 meters per second square. So the force in this case will be 20 multiplied by 10. So it will give you 200 Newton. So the buoyancy force will be 200 Newton. The proper answer is C. Another question. Similar, the buoyancy force that normally act on 1 kilogram of fish. How much? It's 1 kilogram of fish. I give you the mass. We ask you about the force. So 1 kilogram of fish will produce a weight of, obviously, 10 Newton. So the answer is B. Another example, we ask you, what is the buoyancy force act on a ship of weight 20,000 Newton? This is the option here. Give me your answer. Point to observe, ship is floating. When it is floating, this is mean that the weight of the ship will be equal to the weight of the, buoyancy force. So since the ship is floating, the buoyancy force should be equal to the weight of the ship. So which will give you the obvious answer, which is B. This is the last assessment question. It's about Pascal Principle. When we have a U-shaped tube filled with water with pistons at each end, then when pressure is increased at one end of the tube, pressure at the other side, what happened to it? Answer, increase by the same amount, increase more if the area is more, decrease if the area is less, decrease in accordance with the conservation of energy. Which is the proper answer? Think about it and give me your answer. The answer of this quiz is, if you increase the pressures in one end, the other end will also have an increase by a small amount because it has a larger area. With that, we're concluding our presentations and we're concluding chapter 13. And next, inshallah, we're going to talk about chapter 14, which is the gas state of matter. Right. I'm now open for any question. Any question?